Is actually Alan Turing on the right in the 1950s, and he was the first person to say, "Can machines kind of think?" And it is, I believe, it is the Enigma machine, which was used to crack codes in the World War II.
Oh,
So it was sort of the first uh, computer that's seen as like a thinking machine because it was able to do so much computation. Um, and later on in 1956 is when sort of that first the term artificial intelligence uh, is coined, and it was actually at a Dartmouth conference led by John McCarthy.
so wait, is he considered the father of AI?
Yeah, I think Alan Turing is considered that, in some senses, computing itself as well, but modern computing and AI, yeah,
Oh,
Alan Turing.
what are those circular things that look like batteries?
So those are probably, actual bits, mechanical, because so back then they everything had to be analog,
Mm,
meaning that it's not just stored as like a zero and a one. You actually have to uh, store something physical with the information. So in today's computers, you have transistors that just based on the electrical signal within them, they're either at zero or one, and they're tiny, so there's not much energy per one, so there's actually a lot of them. But so this the amount of work that this could do, you could count on your hands. Like, this would be a tiny little piece of a computer. But essentially those are logic gates in an analog form. So
okay, well, what's a
it's a
logic?
lot different now. Logic gate is just something that measures if something is zero or one and
Oh,
does something with that. Makes a Either ends up being zero or one on the outside based on what the input to that gate was. It either is open or closed. And that's sort of how computers are able to crunch all those numbers, right? And so that's Alan Turing. And then in the 1950s, this image doesn't actually go along with this, but there was early AI programs in the 1960s and 1970s where they were using them to solve math problems, games, and like checkers and chess, and it was very logic based, and it wasn't really able to handle these, not really learning necessarily, but just really complex rules and logic they were able to put into things, um, and not able to understand uncertainty and whatnot. But then in the 90s and 2000s is really when machine learning uh, came to be, which is now more of what we're showing here, but specifically with deep learning as well. So when you hear of machine learning and deep learning, that's sort of this new age AI of what we really think about it today being, but allowing these neural networks, as they're called, which are a bunch of those zeros and ones, uh, all stored up, and actually having it learn from data and be able to handle this uncertainty and these complex problems. So in this image, we're looking at specifically image recognition
mm,
and looking at, these are examples that this machine learning model was given the input of these images, and then it outputs the likelihood of these different classes, which are uh, could be a mite, a container ship, a scooter, a leopard, any of these classes you could call them. So this is sort of that 2000s time period,
okay,
2010s.
but how the heck did we get to the moon?
Well,
And
we actually got to the moon way before, yeah. What?
I was like, yeah, how did we get to the moon and we didn't even have technology like this yet?
Yeah, it is actually a marvel how they were able to get to the moon.
Or did we get to the moon? I'm joking.
Yeah, no, just kidding.
Oh, oh,
Yes,
that's interesting.
yeah. So now when we get to this age, right, there's a lot of things that developed over time, and when we talk about the generative AI, when it's actually something uh, a, an AI system that's producing new content, essentially, not just recognizing or classifying things, but rather, generating either whatever, if that's text or images or audio, whatever it is, right? It's actually generating something as an outcome. And this, what we're showing here, right, is sort of that early model that was kind of generating these dreamscapes and it was trained on all this data, but it really wasn't getting that good yet. But you can obviously see that it's pretty interesting. And this is from Google's DeepMind at the time.
Wait, so AI created that?
Yeah, so this was one of the first AI created. Let me go into presenter view here. So it's one of the first AI created like sort of image generation where it was just
Mm.
completely sort of procedurally generated and uh, before that we really weren't getting that close into it, but this was from like one of the first use cases that visualized how neural networks are able to sort of recognize these patterns and generate them. So that was 2015 was when this came out.
Wow.
And then style transfer, which was another interesting point in time, was around 2016, where you could take an image and then give it a style from any other image, right? So you could say in the bottom right, you have this painting here. What is that? The Scream.
Hmm.
And you can then take your original image, A, up here on the top left, and see it in the style of the image, in this case, Scream here. So that was around 2016 when this was starting to happen. And so, just years before we really saw the latest generative AI takeoff where we all know it. But before then, a big change in 2016 again was the first text to image model. And this meant, you could just type in some text here. In this case, a small yellow bird with a black crown and short black pointed beak. And then here's all of the examples of what it actually generates.
You said that's 2016?
Yeah, so this is 2016.
Wow.
Um,
It's not that long ago.
but it's yeah, see, it's so much has changed, but we're talking almost 10 years. I think in this case, a little bit less. But the this was the first time when we could sort of mix together with a text and images and really sort of break out of being confined to input being the same as output. It really felt like so. This was an interesting step and kind of brings us to where closer to where we are today. But you could also do this on images and things were and video and things were getting a little bit more advanced there, especially with what they were able to do. They didn't have Alan Turing's computer, but which would not have been able to render this in the amount of time that it takes. Um, and then more recently, Dolly in 2021, that's when it really took off that you could generate these pretty realistic images based on like a text model. In this case, it was an avocado and a chair, an avocado chair. And then in today's world, we see a lot better images than this. But this was in 2021 when this was going on. And so that's really all I have for the sort of the history of bringing us to where we are.
What's Dolly?
Dolly was it's spelled DALLE. It was one of the first uh, generative image models, one of the image to text models, and it actually was a part of ChatGPT uh, and OpenAI for a little bit. I think you can still access it through that. I think they took it over, um, but it was one of the first image and text models.
Hmm.
Yeah, which was 2021.
I guess that's a good big history or background for us that you've given. And I heard you saying generated coding a lot. When do you think did the shift toward generative models begin and what sparked it?
Yeah, so I think the shift really started to happen in the late tens, and what needed to happen before that was there needed to be computers that could handle that much intense work to do the training and to have these large models that were have enough bytes and data within them that then they can actually understand the information that you're giving it. So being able to store that information, we needed computers powerful enough to do that, and we needed to come up with some new models and architecture of AI or neural networks. One of them being the transformer model. You might hear that a lot. That is really what allowed for large language models to start to exist. So as we know, ChatGPT, all these other ones that are available, um, those are based off transformer architecture, which was actually Google who published the first paper on that. But yeah, one thing that we were talking about in the past as well was these large language models. Like, how do they work? What are they really, right? And we were talking about how we needed these computers that were able to store all this information such in all in one place to be able to work with it and train it and run it through a model. And why do we call them large language models or LLMs? Really, because at least these ones owned by OpenAI and Anthropic, all these companies, they are too large to really run on anyone's personal computer. You need, basically these huge, really expensive chips that are really only good at doing that one task generally, and those are called GPUs. And really, all these models are just taking in your text and then predicting what is the most likely outcome or next piece of text that's going to come after what you gave it as input, what your question was.
So are you saying it doesn't really know, it just predict or give me probably what's the most probable answer?
Yeah, that's a good question. And does it think before it's saying? And I think the answer is no. It doesn't really think. It's just taking in and deciding. I mean, the word deciding is off there because that's also a way to think, but it's just predicting, what word is most likely to come after this. Now, there are models that are called thinking models or reasoning models, but that's not exactly the same thing. They can kind of emulate the act of thinking by essentially running the model uh, through a train of thought or a chain of thought that it's actually going to reason or think about answering the problem and what it needs to do and then give a response from that. So they are able to emulate sort of the act of thinking, but there's nothing really magical going on there besides you're running your input through this model, and it's going to give you, based on its training and how it's set up, it's going to give you the most likely outcome of what is the next piece of text. And when we talk about the text, right, how does the model really see text? It comes down to tokens. So when you hear tokens, that is what the model thinks text is, essentially. And so you're going to convert the input of the model into these tokens, and the output of the model is going to be tokens that you're going to turn back into text. And so you might ask, how many tokens is a word? Well, sort of statistically, it's about 4 letters equals 1 token. But we can also see, we can type in some sample text here and then see exactly, how it breaks down into individual tokens. So usually words are tokens, but
Question, is that how, how some of the models now, they give you a limit? Is that how they know you reached your limit, as they do the tokens?
yeah. So
Oh, okay.
because each one of these pieces of text is a number, so a token is really just a number that represents that specific word to that model, or not word necessarily, but group of text. And so the smaller tokens, like numbered tokens, are usually more common words. And so you can see this 20, 200 to 90 here. We can't exactly see where it is, but it might be tokens because everything else is a very common word. Is it third last token? Yeah, it is the third last token. So 13 is period. Work is 1101, and 20,290 is tokens, which means it doesn't show up very, very frequently in the training data for this model. But if we go here and we say, like, we mess up the word tokens, right? Now it's going to break it down because there isn't a token for that word, token. So now it's breaking it into 3 different tokens. So this is actually going to cost you more, right, to run the model on mistyped words, because this now counts as 3 tokens, which are, just these 3 numbers. So now you spent more tokens because your text that you put in is now more tokens, even though it's same text, it's just switched around.
So essentially, if you are typing, because I've done this into ChatGPT, and you're misspelling words, then you're using more tokens.
Yeah.
Mm.
So that's what tokens mean right there, these IDs. And you can go really deep into understanding these tokens and how the model actually uses that information. But it was a decision by the creators of the model, right, to create these tokens. And that was part of this process here. Lisa, I think you were saying something earlier. You had a question I might not have answered fully.
Yeah, I think you've captured it really well. And I guess what I'm now leaning towards is about um, or probably just spur of the moment question that um, a different question may be asked a couple of ways. So I know people may use the model differently. So I was kind of thinking of how this token efficiency could like affect the cost, speed, the way we are putting in our prompt into the model. So it's kind of interesting that you were able to show that how the tokens work because yeah, even with just a single word may cost may have some um, effect on like how the model would um, guess the next word, I guess.
Yeah, and so in that case that we looked at, there were 64 characters. So in the text that we were typing in. So let's say we typed that in. If we didn't misspell anything with tokens in that case, we would have had 15 tokens that make up that 65 characters. And then if we mess it up, we add now tokens has three because it's spelled wrong. So then you have 17 tokens in that same text that you're sending in, which is 13.3% more. So if you did that on everything, you'd be spending 13.3% more energy and use of these of whatever your usage is of these models, which is important to think about. Uh, and what that kind of brought up in my mind is sort of the trade-off, because there are all sorts of models, right? Even from OpenAI, you can use smaller models, for instance. There's a lot of different places you could go to get them. Meta or Facebook, they have their whole Olama is their platform for sort of this open source AI and use of models. And so there's really a lot there. And there are models who are smaller and cost less energy and cost less to use. Um, but there's trade-offs definitely in what you're getting. And right now, what a lot of these companies are doing and realizing is that just the more energy you spend and more work you give to the computer, whether that's during training or whether that's during inference when you're actually using the model and asking questions, it's going to really help to just make it think more, right? So a reasoning model is running more to think about how to answer the question. So as things are going, it's not necessarily moving towards having a smarter model that's going to have less energy. Because these companies are really competing for having the best, PhD level model that's going to be performing the best in every situation.